In these problems, we're going to practice our one-step conversions. This front part talks about mole-to-particle conversions. In mole-to-particle conversions, we use Avogadro's number, which is 6.02 times 10 to the 23. And the units are atoms, particles, molecules, or formula units. Now, all four of these units can be used at any time. Avogadro's number refers to 6.02 times 10 to the 23 of anything in 1 mole. So if I had 1 mole of marshmallows, I would have 6.02 times 10 to the 23 marshmallows. If I have 1 mole of atoms, then I have 6.02 times 10 to the 23 atoms. So it depends on what you're using the mole for to determine what unit you're going to use. But these 4 units are the 4 most common units that we'll use Avogadro's number with in chemistry. So let's start with number 1. Number 1 says how many moles are equal to 2.4 times 10 to the 24th atoms of copper. So when we work through these problems, our first step is to identify what is given to us and what we're looking for. So we see that we're given this number, 2.4 times 10 to the 24th. That's given to us in the problem. And the question they're asking is how many moles? How many moles? So moles is what I'm trying to find. So what I'm going to do is we're going to use T-charts, which is dimensional analysis, how we've been working them in class, to show our work. All right. In T-charts, we always start off with what is given to us. You always write what is given to you first in the problem. So we have 2.4 times 10 to the 24th atoms of copper. And we are looking for moles. So we know at the end our answer is going to be in moles of copper. So we're not changing what compound we're working with, we're just changing the unit that we measured it with. If I have atoms at the front of my T-chart, that tells me I'm also going to need atoms in the bottom of my T-chart. The reason why I do this is because similarly to in math, where if you had a problem that said 2 times 3 divided by 2, you would cancel out the 2's. We want to do the same thing with our units. We want to be able to cancel out the word atoms because I see that it's not going to be in my final answer. So we need to get rid of it by putting it on the bottom. So then I look and I see that atoms in my conversion factor is associated with Avogadro's number. So I'm going to put Avogadro's number next to atoms. And I see that Avogadro's number is equal to 1 mole. And I never changed the substance, so it's still 1 mole of copper. So if I look at my units, the atoms of copper cancel out with atoms of copper exactly like I wanted. And all I have left is moles of copper, which is exactly what I wanted in my answer based on what I was trying to find. So I can put this in my calculator now. Whenever you're using a number that has scientific notation that says 10 times any exponent, you always want to make sure that you put it in parentheses first. Because if you don't put it in parentheses, your number can change dramatically. So you'd want to make sure that you put these numbers in parentheses when you're plugging it in your calculator. So if I put 2.4 times 10 to the 24th divided by 6.02 times 10 to the 23, and the reason why we divide is because this number is on the bottom of my T-chart. So I divide them and I will get 3.99 moles of copper. And I can balance that just so. And if we scroll down, let's work through problem number 3. Okay, let's work through problem number 3. I'm going to erase our work for problem number 1 so that I can scroll down all the way and bring it front and center. Okay, so problem number 3 says how many atoms are in 3.4 moles of chlorine. So I see that 3.4 moles of chlorine is what is given to me, and I'm trying to find the number of atoms of chlorine. So again, I always start off with what is given to me in my problem. I'm given 3.4 moles of chlorine, and I'm trying to convert to atoms. So I always start off with what's given to me in my T-chart, and I write what I'm trying to find as my final units. Because I have moles of chlorine in my T-chart, I'm going to put moles of chlorine also at the bottom. Now I know I'm trying to convert to atoms, and I know that Avogadro's number converts from 1 mole to 6.02 times 10 to the 23 atoms. So I'm going to put that in my T-chart. I'm going to put my 1 mole on the bottom and my Avogadro's number on the top. And I'm going to use the word atoms of chlorine. So if I look at my units, my moles of chlorine cancel out with moles of chlorine, and what I have remaining is atoms, which is what I want. So when I put this in the calculator, I say 3.4 times 6.02 times 10 to the 23, and I remember to put Avogadro's number in parentheses, and I will get 2.05 times 10 to the 24th atoms. And I'll box in my answer. So remember, we follow the same steps for every problem. We put what's given to us in the front of our T-chart. We put the same unit that's in my given at the bottom of my next conversion factor, and I pick the conversion factor that I'm going to use. Right now, I only have one. I've got Avogadro's number. So if we get rid of problem number 3, and we look at the back side of this worksheet, we will see, and we can actually get rid of all of this now. If we clear all of this out and we go to the back side of the page, this next part says mole to mass conversion practice. So in mole to mass conversion practice, instead of using Avogadro's number, we're going to use molar mass, which we learned to convert in the last video. We talked about how molar mass is equal to 1 mole, and we used our periodic table to help us calculate it. So, in problem number 1, it says, what is the mass of 6.2 moles of potassium carbonate? So, we will start off with what is given to us in the problem, the same way as we did with the front side of this worksheet. We notice that 6.2 moles of potassium carbonate is what is given to us, and we are trying to find the mass. Now remember, mass is how much something weighs, and in chemistry we use grams to measure that. So anytime you see the word mass, you need to automatically think of grams. So let's start off by putting what is given to us in the front of our T-chart. So our 6.2 moles of potassium carbonate. And because I have 6.2 moles, it's moles, I'm going to make sure that I have moles of potassium carbonate at the bottom. Now, for this side, we know that we're using molar mass, but the reason why is because I know that I'm trying to convert from moles to grams. My answer should have units of grams of potassium carbonate. So the only conversion factor that we've talked about so far that has grams in it is molar mass. Avogadro's number does not have molar mass, or does not have grams, only molar mass does. So I'm going to put the molar mass of my compound at the top. So I would take a second to pause this video and calculate molar mass. Okay, good. You should have paused the video and calculated the molar mass of potassium carbonate. If you did this, you should have determined that the molar mass is 138.21 grams. If you did not get this answer, you might need to review and check that you had 2 atoms of potassium, 1 mole of carbon, and 3 moles of oxygen. 2 atoms of potassium, 1 atom of carbon, and 3 atoms of oxygen. And we know that our molar mass is always equal to 1 mole. I can check my units and say moles of potassium carbonate cancel out with moles of potassium carbonate. All I have left with is grams, which is what I wanted. So when I put it in my calculator as 6.2 times 138.21, I get 856.90 grams of potassium carbonate. So that's good. Let's work through problem number 2. Problem number 2 says how many moles are in 150 grams of ammonia. So I'm given 150 grams because that's the number they give us in the problem, and they're asking how many moles. So moles is what I'm trying to find. Again, we follow the same steps. I always start my t-chart off with what is given to me, 150 grams of ammonia. Because I have grams of ammonia at the top of my t-chart, I'm also going to put grams of ammonia at the bottom. And I'm looking for moles. So I know that my answer will have moles of ammonia. Now, the only conversion factor I have that utilizes grams, which I already know has to be in my conversion factor, is molar mass. So again, take the time to pause this video to calculate the molar mass of ammonia. Good. You should have calculated the molar mass of ammonia to be 17.03 grams. And we know that molar mass is always equal to 1 mole of the same substance. So if I look at my units, grams of ammonia cancel out with grams of ammonia, and I'm left with moles of ammonia, which is what I was trying to find. So because moles of ammonia here matches this, moles right here, I'm ready to calculate my answer. So 150 divided by 17.04 will give us 8.80 moles. If you have any other questions about this video or the rest of the problems, please come see me before or after school. In the next video, we'll talk about how we use both molar mass and Avogadro's number in the same t-chart to solve a 2-step problem.